When plants grow slowly or leaves turn yellow, most gardeners assume the seeds were bad or the weather was to blame. However, the primary cause of these failures is usually the condition of the soil itself. We are going to cover a systematic 5-step rehabilitation process. This approach is designed to transform dense, unproductive dirt into a rich, loose environment where plants can thrive. To begin the rehab, you need to gather a few essential materials: high-quality compost, a basic soil pH test kit, coarse organic matter like wood chips, and stepping stones or wooden boards. Using these tools in a specific sequence replaces guesswork with a predictable method. It allows you to address the structural and chemical issues that prevent garden success. Step 1 focuses on breaking up soil compaction. Healthy soil requires microscopic air pockets so that roots can breathe, grow, and spread through the ground without resistance. Diagnose compaction with a squeeze test. If you grab a dry clod of garden soil and it remains a solid brick despite firm pressure, the soil is too dense for most root systems to penetrate. You can fix this by mixing compost or leaf mold into the top layer to create structure. To prevent the soil from packing down again, place stepping stones in your beds so you never have to step directly on the planting area. Step 2 is managing drainage. Different plants have different moisture requirements. While tomatoes and peppers need rich soil that drains well, herbs like rosemary and thyme require much drier conditions to avoid root rot. In compacted clay soil, particles are so tight that water can't move downward. Moisture pools on top, cutting off oxygen to the roots. Adding coarse organic material creates larger gaps, allowing water and air to move freely through the soil profile. Step 3 shifts the focus to biology. Healthy soil functions as a biological system where billions of microbes and fungi process organic matter into nutrients that plants can actually use. To maintain this system, add a 1 to 2 inch layer of compost to the surface of your beds once or twice a year. This provides a steady supply of energy for the beneficial organisms living underground. This creates a mycorrhizal network. These specialized fungi attach to the roots and act as an extension of the plant, scavenging for minerals in the soil and shuttling these nutrients directly to the root hairs. Protecting this biology leads to step 4, stop overworking the soil. Many think new compost must be aggressively tilled deep into the ground, but frequent tilling physically destroys the fungal threads and breaks down soil structure, leaving it vulnerable to erosion and killing beneficial organisms. A no-dig approach is more effective. When you layer compost on top, earthworms and microbes pull that organic matter down for you, creating natural tunnels that keep the soil aerated without mechanical damage. This is why avoiding foot traffic is so important. Walking on these beds collapses the tunnels created by the biology, undoing the work of the earthworms. By providing organic input and minimizing disturbance, you build a self-sustaining ecosystem. The soil biology will eventually handle the aeration and nutrient delivery automatically. Step 5 addresses the chemical balance of the soil. Even with good structure and biology, an incorrect pH level can prevent plants from absorbing the nutrients already present in the ground. This is nutrient lockout. It occurs when unbalanced soil chemistry holds on to nutrients, making them impossible for roots to collect. As the pH slider moves towards acidic or alkaline extremes, nutrient availability bars shrink. The plant starves despite high-quality compost. To determine your current levels, perform a basic at-home pH test. Match the color of your soil sample against the reference chart to identify your baseline number. You can then make specific adjustments based on your results. If the soil is too acidic, adding lime will raise the pH. If it is too alkaline, elemental sulfur will lower it. Optimizing the pH is the final step in the rehab. It ensures that your plants can actually access the physical and biological environment you have built. This 5-step process transforms a bed of stagnant dirt into a functional ecosystem that is loose, draining efficiently, biologically active, and chemically balanced. Fixing these foundational issues makes maintenance more efficient. Water reaches roots faster, and the loose structure lets you remove weeds with much less resistance. Great gardening starts underground. When the soil environment is correct, the plants have the resources they need to grow strong and resist disease. Now that you have a plan for rehabilitating your soil, the next step is learning how to build new beds from the ground up. Click the next video to see how to construct rich, living garden soil from scratch, and subscribe for more ways to improve your garden.